Since a long time ago, people have been really interested in exploring caves. But what happens if the cave is too small for someone to fit in? That's where exploration robots comes in. But most of the time, these exploration robots are too expensive.
In order to solve our problem, we came up with a solution to build a simple walking robot, which is very compact so it can enter a very small and narrow area. Most of the body parts is built from 3D printed materials, which is polylactic acid. We also use recycled material for the parts such as the blades and turntable. Hence, it will be a very cost-effective robot.
Two IR sensor modules are mounted at both the legs of simple walking robot to sense the track line or can be modified to sense obstacle, while an IR sensor module is fixed in front to let the robot stop when it senses obstacle.
The high torque motor is aided by a small driving gear which is connected to two large driven gears. This is designed to help the motor to lift heavier loads. This motor is one part of the turning mechanism, which will be explained in details later. We use L29AN model motor driver, which is to supply high voltage to the motors and also allow speed and direction control by the microcontroller, which is Arduino Uno.
There's an LDR connected to the robot which allows the robot to sense the brightness of its environment, and if the environment is dark, it will turn on an LED. There is a limit switch at the bottom of the body of the robot, which allows the robot to sense the position of its legs to help in detecting the lines by the IR sensor. At the bottom of the robot is a turntable which allows the robot to turn easily when the top motor is spinning.
So now we will demonstrate the working mechanism of our walker robot. When the push button is pushed, the motor will start driving the gear to move the legs. The leg will lift the body and then the body will lift the leg over and over. This process will be continuous and the robot will stop once the IR sensor detects an obstacle.
Now we are going to demonstrate the turning mechanism of the walking robot. Once the IR sensor detects the white line, the top motor will start spinning, giving the robot a moment in the opposite direction, just like in a helicopter. And now we can see that the robot is slowly adjusting its path. Once the IR sensor leaves the white line, the top motor will stop spinning and the robot can continue walking in a straight line.
For the lighting system, when the robot enters a low brightness or dark areas, it will turn on its LED and turn off when the surroundings become bright again. We are at the running track now, and we are going to demonstrate that the robot is able to walk for a long distance. We set the distance to be about 10 meters. The walking mechanism of simple walking robot is working normally as expected. And finally, the robot has successfully reached its destination.
Hi everyone, we are from Group 3 of EEN 355 Calculation System of USM KKJ. And this is our walking robot. I'm Theo Jensen.
My name is Amir.
And I'm CHANG.
After all the demonstration done, we have proved that our simple walking robot is a successful case. That's all from us. Thanks for watching our video. Bye.